Okay, today we're going to talk about a new kind of measure for an angle. Up until this point in your math career, you've probably pretty much been talking about 360 degrees as a circle, degrees in a circle. However, for many physical applications, a degree measure doesn't make much sense. For example, if you're talking about analyzing a sound wave, a degree doesn't make any sense in that situation, nor does tides going in and out. Those kind of situations don't lend themselves to be able to be used, talk about degrees. So we introduced a new measure called radians. If I have two circles, this angle is the same for both of these circles. Okay, so it'll cut off an arc length and it'll cut off another arc length. In our case, we're going to call S is what we're going to call arc length. So an arc length is the length on the circumference of the circle. Right? So if we have the same angle in both of these circles, it's going to cut off a similar piece of pi. However, if you have the same circle and you have an angle here, it'll make an arc length here, whatever it is. If the angle is bigger, it naturally is going to make a larger arc to that circle. Okay? So what we're going to define is a radian measure of an angle is equal to the arc length divided by the radius. So this angle is proportional to the arc length, whatever the arc length is, to the radius. In this case, the circle will be the same size, the radius will be the same in this circle. However, if you have a larger arc length, you will have a larger angle. If you have a smaller arc length, you will have a smaller angle. So the angle is proportional to the arc length. And that proportion we're going to call a radian. Theta in radians is equal to the arc length divided by the radius. Since radian is a ratio of the lengths, it's a ratio of the radius to the arc length. Since it's a ratio of the lengths, it is a unitless measure. So it doesn't have any units to it. It's not like feet or inches or seconds. It is just a measure of the ratio of the circumference of the arc length divided by the radius. So let's take a closer look at a radian. One rotation around a circle is 360 degrees. That's what you've learned in previous math courses. One rotation also gives an arc length. If you're looking at the circumference of the circle, it gives you an arc length of 2 pi times the radius, whatever the radius is. Then one rotation in radians is 2 pi r, this thing, the arc length, divided by the radius. You cancel the r's, and then one rotation in radians is equal to 2 pi radians. So one rotation is equal to 360 degrees. 360 degrees is also equal to 2 pi radians. All right? A half a rotation is equal to 180 degrees. So if I divide this by 2 and divide this by 2, I get that that's equal to pi radians. A quarter rotation is equal to 90 degrees. If I divide this by 2 again, I divide this by 2, because a half to a fourth, then I get 90 degrees is the same as pi over 2 radians. This helps us to find a way to convert between degrees and radians. Converting from degrees to radians. In the last slide, I showed you that 180 degrees is the same as pi radians. If you divide both sides by if you divide both sides by 180 degrees, that means that 1 degree would be equal to pi over 180 degrees in radians. Pi radians over 180 degrees. So that gives us a conversion factor. To convert from degrees to radians, multiply your degree measure by pi over 180. For example, convert 225 degrees to radians. 25 degrees times pi over 180. If I simplify this a little bit, that would give me 3 pi over 6 radians. Going the other way, if you have radians, can you convert to degrees? So converting from radians to degrees. Similarly, if 180 degrees is equal to pi radians is also equal to 180 degrees. We divide both sides by pi, so that gives me 1 radian is equal to 180 over pi degrees. So to convert from radians to degrees, multiply the radians by pi, 180 over pi. For example, convert 3 radians to degrees. 3 radians times 180 over pi. That gives me 540 over pi. And pi is the same pi you've always known as 3.14159. Divide this pi into 540 degrees, and that's equal to approximately 171.9 degrees, which makes sense. If pi radians is 180 degrees, 3 radians, remember this would be 3.14 radians, is equal to 180 degrees. 3 radians should be a little bit less than that. And in fact, that's exactly what we find.